All right, here we go. Next question. So in this question here, we see the question sentence immediately say, what is the average speed for the entire trip, including the break? Okay, including the break. We got to take a break into account. I don't know where that break comes in. I kind of see it right here, but we'll tackle that as we get to it. So what we want again is the average speed for the whole trip, and we are including the break. We're including it. So here's how we want to think of this. If we want the average speed for the entire trip, we will need the distance and the time for the entire trip. So distance equals rate times time. That's what we want to plug into, but we have to be consistent. So when we take a look at the information that we see that we have a bus travels 180 miles at 60 miles an hour. So we can consider that part one. Then we take a 1 hour break. And then we see over here in purple that we travel 60 miles in 2 hours. So we have the three parts here. So let's get to work here. First, we see 180 miles. And then we see 60 miles. But then we have that break. Everyone, can we clarify something really quick? When we take a break for an hour, what is the distance that we cover in that time, in that break? The distance covered during a break would be 0. It's a break. We're not doing anything. We're just hanging out, probably reading the newspaper, doing our thing, but we're taking a break. So boom, what we'll do is we'll find the total distance, again, for the whole trip, and we have the 180 miles. Then we have 0 miles because of the break. And then we have 60 miles for that purple part, the last part of the trip. When we add everything up, we see that we get 240 miles. That's the whole distance. That's everything here. So boom, we have 240. And then from here, we'll go ahead and try to figure out what that time is going to be for the entire trip. So when we take a look at the purple part, the third part of the trip, we see that it says 2 hours. Nice and easy. Everyone, how long was the break? How many hours was that going to be again? Right there, booyah. Yeah, that's just 1 hour. And then lastly, if we want to figure out the time for that first part, well, we have to do a little bit of math because we see 180 miles right there, 180 miles at 60 miles per hour. So we'll do a little math here on the side and we'll write our distance equals our rate multiplied by our time, divide both sides by 60, and we end up getting the time being 3 hours for that first part. So boom, 3 hours right there. All right, we're ready to go. What is that total time going to be? Well, we add everything up. 3 plus 1 plus 2, that'll be 6 hours. Again, we are including the break. So we will include that 1 hour. Booyah. R times 6 hours. And now we're ready to solve, everyone. Now we're ready. We are going to divide both sides by 6 to get our final answer. And that gives us a final rate of, right over here, 40 miles per hour. And there we go, everybody. Boom, that is bingo. And let's go ahead and mark this here. Correctly is answer choice C. Hopefully this is a fun one. Hopefully you're ready for more. All right, so tackling this next question, as always, doesn't matter how short or extensive a problem might feel, we always want to start with that question sentence no matter what. So here it says, how far does it go? And when we look at the answer choices, don't worry about the numbers. They all say miles on them. So everyone, my party people, when we think about, hey, how far does something go? And we think about miles, what kind of a unit are we trying to find? Yeah, we're trying to find distance there. Absolutely. We are absolutely trying to find distance. So, boom, we understand that. How far tells us distance. And if we take a look at these clues that we're given, hey, a bus travels at 48 miles per hour for 2.5 hours. Oh, yeah, for sure. We are looking at a distance, rate, and time question. Now, before I even get to the reason why, I want you to answer that for me. Because sure, 2.5 hours, that's time. This is distance. But what gives away that 48 mph is a rate? What gives it away? The word per. Yes, the word per. Because we see miles and we see hours, but the word per is what connects them together. That's what speed is. How far do you go in this amount of time? Miles per hour. So I really need to repeat that, especially as we go through problems like this. But here we go. So we have 48 miles per hour, 2.5 hours. The formula is distance equals rate times time. And remember, this is what we're looking for. So when we plug in the values that we have, like 48 for the rate and 2.5 for the time, notice that we don't need to work backwards. We're just going to multiply and we're set. Now, obviously, we have to bear in mind that if we're not comfortable with decimals, it might make this problem a little tougher than it needs to be, but I entrust you to work on that as time goes. So here, we have 48 multiplied by 2.5. Let's work on it together here. Multiply, ignoring that decimal. And then from there, we'll bring that decimal back. So here we go. 8 multiplied by 5, that's going to be 40. So we'll place a 0 and carry that 4. From there, we have 4 times 5, and that's going to be 20. Carry that 4 gives us 24. So there's our first line of work. Boom. This 5 is done and dealt with. When we move forward to the 2 over here, we're going to begin by first placing a 0 because remember, we are going to start where that 2 is. So then we have 2 times 8. That'll be 16, and we'll carry that 1. And then we have 4 times 2, which is 8. Carry that 1, and that's 9. So now we're going to add these back together, and then we have 0. 4 plus 6 is 10. Carry the 1. And then we have 1 plus 2 plus 9. So that'll end up being 12. So I know this looks like 1200, but it's not quite 1200 because we're going to bring back how many decimal places? How many decimal places are we bringing back, everybody? Yeah, just the 1. Just 1. And we know that because, again, right there, that's where that decimal existed. Nothing up here, so we're good. So we just bring 1 back. So there we are. 120 miles is the distance that we cover. And boom, that is answer choice B. My party people, pop quiz time. Hit me with the formulas for, oh wait, it actually doesn't even say specifically. So let's work on this real quick. What is the distance around the edge of the circular driveway? Everyone, if we're discussing a circle, and again, I draw perfect circles, but if we're talking about a circle, everyone, what do we call the distance around a circle? What do we call the distance around a circle? That's right. It is going to be the circumference. It's going to be the circumference. We are looking for the circumference. And we said there are 2 formulas. We said it ourselves. One formula will be the circumference equals 2 times pi times the radius. And the other one will be pi